Oppan Gangnam Style. Gangnam Style. Oppan Gangnam Style.
Well, hello and welcome back. Our topic today is transformations of functions. So, the beginning, there's four things we want you to get out of today, four main translations that we're going to talk about. So let's go ahead and dive right in here. The first one is a reflection over the x-axis. So here's our rule. We're going to say negative f of x is a reflection over the x-axis. And basically what we want you to get out of this is f of x is just fancy for y. So when you negate the y values, you're really reflecting over the x-axis. So let's go ahead and put a little asterisk there and say we are making the y values negative. And let's go ahead and make a sketch to kind of go along with that. So we'll take any random function, we'll just call this f of x. And we're going to say, okay, let's graph negative f of x. So what we want you to understand is we're going to say to yourself, okay, I am making the y values negative. That means I reflect over the x-axis. So basically, you're just taking what's below the x-axis and now making it above, and what's above now making it below. So hopefully you can kind of picture that in your head. This is going to reflect over. This section here that's above is now going to come below. This section that was below is now going to become above. And then this section that was above is also going to go below. And I'm going to say that's negative f of x. Rule number 2. This time we're going to reflect over the y-axis. So the rule's just a little different. Here it goes. This time it's going to look like f of negative x. And you'll notice this time I am making not the y negative, but the x negative. Okay? So I'm making the x negative, which means I'm going to reflect over the y-axis. So let's go ahead and sketch a function that might look like that. So I'm going to try to draw a similar function there. And we'll say that's f of x. And if I want to sketch f of negative x, in my head I'm saying I'm making the x negative, so that means reflect over the y-axis. Alright, so here's the y-axis. So I'm just going to go sideways. It's kind of like when you were, maybe you were a kid and you used to fold a paper in half and make a heart, kind of cut it out. That's basically what we're doing. And the y-axis is like that, is like that line that we folded on. So basically, this part here is going to reflect over here, and this part here is going to reflect on this side. And hopefully you'll agree that looks like f of negative x. I should be matched up. I see this line here. This should match with this. This piece should match with this piece. So again, it should be a reflection over the y-axis. So I like to think of it two ways. Basically, I say to myself, you're kind of doing the opposite. Okay? If you notice that you make the x negative, you actually reflect over the y-axis. Okay, so if you make the x negative, reflect over the y. If you notice you're making the y negative, do the opposite. Reflect over the x-axis. And those are the two things I say to myself all the time. Am I making the x negative or the y negative? And then reflect over the opposite one. All right, go ahead and get this sketched in your notebook. This point here, we've got a nice x-axis. This is at 1, this is at 5, and then this is at 4 here. And we'll just label it f of x. Alright, so we're going to apply the two rules that we just talked about. So letter A, we're going to sketch f of negative x in one color. And then if you've got colored pencils, that's great too. And then we'll sketch negative f of x another way. So the first thing I say to myself, a lot of self-talk here, I'm making the x negative. Okay, so that really means reflect, hopefully you've guessed it by now, over the y-axis. Okay, so basically I'm saying here's my y-axis. I need this image to appear on this side. Okay, so here's my y-axis. Basically, I just need this to come down, and that'll be at -1. And again, it should be a mirror image. And I'm going to label this f of -x. So if I make my x negative reflect over the y. All right, let's try the part B here. If I say negative f of x. Okay, so this time I'm saying I'm really making the y negative, which means I'm going to do the opposite. Reflect over the x-axis. Okay, so this time I basically want to take this graph, my original f graph, and flip it over the x-axis. Okay, so it's going to come across, and then hopefully it's going to shoot down. And it should look like a reflection, like you could fold on the x-axis, and this piece should land on top of this piece. And I'm going to label that negative f of x. Okay, well we've covered 2 out of the 4 topics we need to get down tonight. So our next 2 topics deal with the word translations. Now perhaps this word sounds familiar from your geometry days. A translation is just a fancy way to say a shift. Okay, so you're not doing any reflecting. You're basically picking something up and moving it. You're shifting it. Now your options are, you can either go right or left, or you can shift up and down. And we're going to talk about those 2 types of shifts. Those would be the following 2 that we have left. So the first one that we have left here is going to be f of x plus a. All right, and this rule is very important. When you see this, you're going to have to interpret where it's shifting. Is it shifting left to right or up and down? So here's how I like to attack it. The first thing you'll notice is that the a is inside the parentheses. And that's the big deal. Where is it sitting? It's inside the parentheses. That tells me that this is a horizontal shift. Okay, now hopefully that word horizontal means something to you. You can think horizontal like the horizon, which means left or right. The second key thing you need to get out of this is which way it's actually shifting. Now the horizontal shifts go in the opposite value of A. So if you see a plus A, you are actually going to shift it to the left A units. If you saw a minus A, you would actually shift it to the right A units. So you're just going to do the opposite value of what you see. So let me give you an example. Go ahead and sketch this with me. And we'll say this function here is f of x. We'll pretend it hit there right at 2. And we're going to take that function and we're going to shift it someplace. So here's our question. Sketch f of x plus 3. Okay, so here's what should be going through your head. This 3 is in the parentheses, which means it's a horizontal shift or horizontal translation. And because it's a positive 3, I'm going to do the opposite. I'm actually going to shift it left 3 units. Okay, so it's basically, it's like taking this picture you have and you're just going to move it over 3 units to the left. So if you're sitting currently at this point is at 2 and you move it 3 units to the left, hopefully you would say it's now at -1. So basically I went from 1 to 0 to 1, and I'm going to plot that new point. This value up here is when x equals 0, and I'm just going to move it 3 units to the left. So 1, 2, 3, that would be at -3, and it's still going to be at the same height. I'm just picking it up and shifting it. And now I'm just going to connect those. And there you have it. This is f of x plus 3. Okay, no calculator needed, nothing fancy. We just have to recognize when it's inside the parentheses, horizontal shift, and you're going to do the opposite. Let's draw one more graph on the same picture here. Let's say we wanted f of x minus 6. F of x minus 6. So here's what's going through my head. The 6 is inside the parentheses. Okay, so that's telling me horizontal shift. I see a -6, so I'm going to do the opposite and go right 6. Okay, so I'm just going to take my original f of x, which is my red graph, and I'm going to move the points I have to the right 6. So this 2, if I move to the right 6, 1, 2, 3, 4, 5, 6, should now be at 8. And this value 0, if I move it to the right 6, should now be at 6. And again, I'm just going to sketch this graph. Just a nice quick sketch. And that's f of x minus 6. All right, last translation we have to talk about is going to look like this. F of x plus a. Now you'll notice this is a little different from the previous one. Notice where the a is sitting, and that's the whole catch. Is the a inside the parentheses or outside? Hopefully you can clearly see that it is outside the parentheses. So what this tells me is when it's outside the parentheses, this is actually a vertical shift. Okay, which means you are going to shift the graph up or down. Now, unlike horizontal, where you did the opposite, you are literally going to shift exactly what you see. So a positive a is going to move you up a units, and a negative a is going to move you down a units. Okay, so again, it really depends where the a is sitting. Is it inside, means horizontal, outside means vertical. So let's take a look at an example. Again, go ahead and sketch this with me. Give ourselves a nice x and y axis. We'll start with this random function f of x. And we'll draw two graphs. All right, the first graph, we're going to say take f of x and add 3. Okay. So all I'm saying to myself is because this 3 is outside, this is telling me vertical shift, and I'm literally going to take the graph and move it up 3. So I'm going to start at this point, and let's just say this point has a height of 2. If I were to move it up 3, 1, 2, 3, I would now be at 5, and I'm going to put a dot there. I'm going to take this height that's at 0 and move it up 3. So 1, 2, 3, and put its new point there. And then I'm just going to connect them. Okay, I'm not changing size, I'm not changing shape, I'm just shifting up 3. And we'll label that f of x plus 3. We'll squeeze one more in there, part B. If I said f of x minus 2. Okay, again, all I'd say to myself is this 2 is outside the parentheses, so that's a vertical shift, and I'm literally going to go down 2. So I'm going to take this original red graph that I have, and I'm going to move my points down a height of 2. So this was at a height of 2. If I move it down 2, that puts me at 0. This was at 0. I need to move it down 2, which puts it at negative 2. And a nice smooth curve, and we've got it. All right, here's a common question that you'll find throughout our exam here. It says, given the graph of f of x shown below, sketch the graphs of the following. And it gives us a through e. So basically, I'm going to take this graph and I'm going to sketch it 5 different times, 5 different ways. So let me start with the first question, a. F of x plus 1. So you've just got to know, are you shifting horizontally or vertically? And hopefully you're saying to yourself, you're inside the parentheses, so take a guess on your own. I would definitely say that's a horizontal shift. Okay, now horizontal, you're going to do the opposite. So if I see a plus 1, I'm actually going to go to the left 1. So I'm going to sketch my graph right on there, and you can sketch it in your own notebook. I'm going to shift this whole graph left 1. So the 2 is going to move over 1, this guy's going to move over 1, this guy's going to move over 1, that one's going to move over 1. And then I'm just going to nicely connect them. Okay, so I should be the exact same size, the exact same shape. I'm just shifting the graph left 1. All right, letter B. F of x minus 2. All right, so same thing, lots of self-talk. Are you inside or outside? Okay, I would say the 2 is clearly outside. So that's telling me that's a vertical shift. And I'm literally going to do what I see on a vertical shift. I am going to move this graph down 2. So I'm going to take all my points and just shift them down 2. So this point at 0 now moves down here. This point at 2 moves down 2. This guy's going to move down 2, and this guy's going to move down 2. And I'm just going to take the clear endpoints, and then I'll just connect them. And that is f of x minus 2. All right, a couple more to go. Letter C, f of negative x. So this time I'm saying to myself, I'm making the x negative, so I'm going to do the opposite. I'm actually going to reflect over the y-axis. Okay, so take a minute, sketch that graph on your own. You're reflecting over the y-axis, so you should be able to fold on the y and it should appear on both sides. So I would say that's going to come over and look like that. Looks like it matches up. It's going to go 2 that way and up that way. It should be a perfect reflection over the y-axis. Letter D, negative f of x. Okay, so you'll notice this time I'm saying make the y negative, which is a reflection over the x-axis. Those were the first 2 rules. So I should basically be able to flip function f of x over this line and see the same thing. So that's going to come down 2, across 2, and then down 2. And again, hopefully you can see if you were to fold on that line, you'd get the same thing. Now, lastly here, letter E, just kind of threw something new at you. Basically, E is saying 2 times f of x. And remember, f of x is just fancy for y, so I'm really saying 2 times every y value. Okay, well, we're almost there, I promise you that. Just a couple more things. If I give you the graph of y equals x squared, all right, we should all know what that looks like. Hopefully you're saying that's a parabola, starting at the origin. Okay, and I tell you to shift it 2 units to the right. You should be able to write the equation of that graph. Okay, so here's what should go through your head. If you're shifting 2 to the right, that's a horizontal shift. So you want to be inside the parentheses. Okay, so I'm going to say that's something squared. And I want 2 inside the parentheses. And if I'm going to the right, well, the right is usually positive numbers, so I'm going to put the opposite in. I'm going to say that's the quantity x minus 2 squared. And that should tell me inside, this is telling me horizontal shift, and this is telling me right 2. I'm going to do the opposite. If I told you, take that equation, y equals x squared, and shift it 4 units up, you should be able to write the equation. So I would say y equals, okay, if I want to go up and down, I'm not inside the parentheses. So that's going to be x squared plus 4. Notice I'm outside the parentheses. Technically they're around here if I need them. And this is shifting me up 4. Now this will work the same way no matter what your function is. So again, these rules will work for any function. Let's take the absolute value of x. And hopefully you remember we did this, I don't know, the second week of school maybe? Absolute value makes that v at the origin. Okay, and we should be able to shift that absolute value graph anywhere we want. Let's say we wanted to shift it up 4 and right 2. What would the equation look like? Well, here's what I say to myself. Up 4, up and down is going to be outside. Right 2 or left 2 is going to be inside. Okay, now I don't have parentheses this time, I have absolute value. So here's what my equation should look like. Y equals the absolute value of x. Now if I want to go right 2, remember horizontal, you're going to do the opposite. I'm actually going to say minus 2. And from there, if I want to go up 4, I'm going to go plus 4. So again, inside is my horizontal shift, and I'm going to do the opposite. Outside is my vertical shift, and I'm going to do what I see. So this is telling me to go up 4. This is telling me to go to the right 2. So I can move this to the right 2 and up 4. And I'm just going to redraw my v graph, or absolute value graph. All right, let's try this one without drawing it. you have the function x squared, which again should make a nice upward-facing parabola, and you want to shift yourself down 3 and left 2. What would the equation look like? Okay, so you should have something inside and something outside. Okay, I'm going to start with my x. If I want to go left 2, okay, that's my horizontal shift. That's what goes inside, and I'm going to do the opposite. So left 2 would be a minus 2. I'm actually going to put in a plus 2. So that's telling me horizontal shift, left 2. Outside, if I want to go down 3, I'm literally going to say minus 3. And this will be a vertical shift down 3. Okay, so it's all about inside or outside the parentheses. All right, just a few more to go here. Sometimes they're going to give you a picture of the graph, and they're going to want you to write the equation. So the first thing I say to myself is, what am I staring at? Is this x squared, x cubed, absolute value of x? Well, hopefully you're saying it's a parabola. I know this has something to do with x squared. Okay, so now I just got to talk myself through the shifts. So I'm going to put my x squared, and I'm going to leave room for something inside and something outside. So I'm going to start with my inside. X squared normally starts at the origin here. So where did I move? Well, let's count over to this vertex here. I moved 1, 2, 3. I would say right 3. So if I want to say I went horizontally positive 3, I'm actually going to put in a negative 3. And then I'm going to say, okay, from the origin, I went down 2. So that's going to leave me with an outside of minus 2. Okay, so again, horizontal is inside, vertical shift is outside. All right, so let's go ahead and sketch this again, and our goal is to write the equation of this graph that I see. And I'm going to label that vertex. It looks like I went left 2 and up 3. All right, so I asked myself, who am I staring at? Is this an x squared, an absolute value, an x cubed? Well, hopefully you said it's making a v, even though it's upside down, so it still has something to do with the absolute value of x. All right, so I'm going to leave some space. Okay, inside is my horizontal, and then outside should be my vertical shift. All right, so horizontally, remember absolute value normally begins at the origin and makes a v, so I would say I went left 2. Which means I'm going to put inside a positive 2. I'm going to put the opposite. And then vertically, I start at the origin. I would say I went up 3, so I'm going to put a plus 3. Now you'll notice something else is different. This V is flipped upside down. Or you could say it's reflected over the x-axis. Okay, in order for this V to become upside down, it's flipped this way upside down. So if I reflect over the x-axis, that means I make my y negative. Okay, remember you do the opposite. So for the moment, I'm going to put a negative in front of the y. Now, of course, we're not going to leave it like that. I need to bring this negative to the other side. So I'm going to say this is y equals negative absolute value of x plus 2 plus 3. This negative here is telling me that I reflected over the x-axis. Well, there you have it. We're going to get a lot of practice in tomorrow in class. Let me just quickly recap the 4 rules. Okay, horizontal shift. Okay, you are adding inside the parentheses, or absolute value, or whatever it may be, and you're going to do the opposite. Vertical shift, you are adding outside the parentheses. Okay, and again, that's outside the parentheses, and you're going to do exactly what you see. Lastly, if you reflect over the x-axis, you're going to make the y negative. Okay, and remember f of x is fancy for y. And if you reflect over the y-axis, you're going to make the x negative. And there you have it. You've got our 4 transformation rules. So good luck, and we'll see you tomorrow.